Hi, this is the Silent Vote project built on Midnight. My name is Jaden.
My name is Shriram.
My name is Nilesh.
My name is Isaac.
And we're going to be talking about how we implemented Midnight into a decentralized application. So Silent Vote is a privacy-focused decentralized application inspired by the American presidential election scandals of 2020 and the recent 2024 election. It leverages non-interactive zero-knowledge proofs to create a complete zero-trust architecture that allows for trustworthy yet anonymous voting. All information is secured with the smart contract on the Midnight blockchain and connects to users over the Silent Vote web application. This web application relies on four fundamental proofs. One, proof A verifies that a user is eligible to vote and the election is running. Proof B verifies that the user and time are eligible to check results, meaning only certain people can see the results of the election after the election is complete. Proof C verifies that a user has voted successfully, which tracks the progress of the election. And Proof D verifies that the results of the election are actually what the users voted for, meaning that users can verify whether election results are valid and untampered with. And these four proofs form the basis of all online transactions, meaning that this platform can be extrapolated to all forms of online transactions. Now I'm going to pass it off to Sriram, who worked on the front end.
Yeah, so I worked on the front end, so we used Chakra UI and React. So if we go back to the home page, so it looks like a cool particle system. And then if you scroll down, you can see Silent Vote. So Silent Vote is the next gen voting platform, and then you can see that we do use zero knowledge proof and blockchain technology, and we use Midnight for this. And then we have a few pages here, so we can get started with voting, and then check election progress for admins, and just learn more about Silent Vote. So I shown before, this is our kind of infographic of how Silent Vote works. So here's how you can vote. So if I type in John Baker, so you have to be a registered voter, and that's already in a list somewhere, but you can't see that. So if you say I vote for a candidate, and then we can see that it does encrypt your vote, and then it is encrypted and it's recorded successfully. So we can see overall progress right here, and also see results. And then results will not be shown until the election is completely ended. So while the election is ongoing, that there will be no, it's kind of secret where it's you don't see that until the very end, so you can't see who voted so far. I'll pass it off to Manish.
So on the topic of how Silent Vote and Midnight are related, so the core of Silent Vote is centered around privacy and trust, and Midnight's blockchain infrastructure is specifically designed for this. While we're still in the early stages of implementing this, we want to imagine what Silent Vote would look like with Midnight smart contracts fully implemented. So Midnight enables decentralized transactions of sensitive data perfect for voting, as it eliminates reliance on a central authority while safeguarding each vote's confidentiality. In Silent Vote, smart contracts would essentially allow Midnight to automate critical rules, beginning with voter verification to ensure that they don't vote twice, ensuring each participant is eligible without revealing their identity. Using Midnight's zero-knowledge proofs, voters would prove their eligibility to the contract while remaining anonymous. Once a vote is cast, another smart contract would record it immutably on the blockchain, allowing all participants to verify the outcome without compromising voter privacy. This contract would prevent multiple votes from the same user, thanks to Midnight's unique ability to execute secure, self-reinforcing rules. Beyond transparency, the flexibility Midnight offers in designing security protocols means we can create tailored protections against fraud, adapting seamlessly for large-scale voter applications. While our current phase doesn't yet fully include the full implementation of smart contracts, our goal is to fully implement this with Midnight's platform to the fullest potential, turning Silent Vote into a truly trustworthy and private voting solution. With the powerful framework, we see Silent Vote as not only a viable alternative to traditional voting, but a model for privacy-focused applications across various fields. Now I'm gonna pass it off to Isaac.
Okay, so the Midnight Network is a dual ledger system with a unshielded ledger and a shielded ledger. So in the unshielded ledger, it does not contain metadata, and so what essentially you can see is that your vote is successful. Right? So in the second part, for our shielded ledger, it uses a zero knowledge proof, and this no one can see. So this is actually stored locally, and so basically what it does internally is it casts all the votes and summarizes everything. And so since it's stored locally and no one can see it, even the admin, the person hosting it, can't see it. So after the time frame, right, then anyone can see the results because the time frame ended. So everything that is stored locally gets uploaded to the results page, which eventually shows who won. And so to summarize it, these 4 proofs, I'm going to pass it on to Jaden as he was talking about the 4 proofs.
Yes, so Silent Vote effectively uses these 4 proofs as a successful and complete proof of concept of what an actual voting platform would look like on the Midnight blockchain. And this really does form the basis of all online transactions. And other blockchains that use a similar zero trust architecture will probably be the future of all online transactions. So hopefully this project can inspire other teams and organizations to implement and produce a functional ecosystem that supports zero trust architecture blockchains. So thank you for listening to our presentation.